Hello, everyone. What I want to finally talk about in this short video is full immunization. This is a almost magical kind of result, an idea here. So the idea is, or the concept is as follows. Let's say we have a very, very, very special kind of portfolio of assets and liabilities. In particular, we have three times T1, T2, T3. Whatever they are, they could be anything except T1 is smaller than T2, smaller than T3. And let's assume we have two assets at T1 and T3, and in between, we have a liability. So what we want to do is fully immunize ourselves against interest rate changes. So remember, we have a surplus function. It's present value of assets minus present value of liabilities. If you want to go back and watch Reddington Immunization Part 1, kind of go review a discussion of the surplus function, et cetera, et cetera. I don't really want to do that here. And so what full immunization is if in this very special situation, I don't think there's any other situation where this works, but in this very, very special situation of asset, liability, asset, really asset, liability, asset, if the if the derivative and the original surplus function at some interest rate is zero, then for any other interest rate, the surplus function is non-negative. Or more practically, same thing. If the two present values and the derivatives are equal, then the present value of the assets is bigger or equal to the present value of the liabilities for all I bigger than zero. And again, if you go back to the video Reddington Immunization Part 1, there's a whole discussion on why that means essentially your company is solvent under the fairly unreasonable assumption that the assets and the liabilities are priced at the same interest rate. That doesn't really make sense, if you have I mean, in some sense, that doesn't really make sense. But anyway, it's just a simplistic assumption. And I don't think I mentioned this before, but another kind of criticism of this topic, which is unrealistic, is it assumes a flat term structure of interest rates. What the hell does that mean? Well, as we remember, typically, not always, but typically, as you hold on to an asset longer, so if you have like a bond that has a long maturity, the yield rate for that is typically larger than a short-term bond. Because in order to invest, in order to entice someone to buy a long-term bond, in other words, in order to entice someone to lock in their money for a long period of time, you need to reward them with the high interest rate versus locking in your money only for a couple of months. Who cares? Guaranteed money for a couple of months. The money's liquid soon after a couple of months. So you're often willing to take a small yield rate when you invest your money for a very short period of time. This video and the past two videos on Reddington immunization do not assume that. But I think to kind of fix the problems I mentioned, you would look at a financial risk management book. But anyway, everything we're doing is for exam FM purposes. So, all right. So there's not much to this. And before I do an example, again, just like with Reddington immunization in the last video in particular, it makes your life a little easier. Here, it's not much easier, but it still makes your life a little easier if you price everything at the time of the first asset. For Reddington immunization, you just want to price everything at the time of your first asset or liability. But here you have an asset, liability, then asset. So, you're going to start off with an asset. So, yeah, you want to price everything at the beginning, at the time of your first asset. And if you do that, and the present values at this T1 are equal, and the derivatives are equal at some given interest rate, then for any other interest rate, the present value of assets is going to be bigger or equal to the present value of your liability. All right, so some of these problems mathematically can get a little funky. I would say absolutely pointlessly funky, but yeah, I've said many times in these videos, Exam FM, there's a lot of pointless crap on Exam FM, which I mean, as a math person, it's kind of fun. It's just, you know, as an actuary, you're not a math person. You're a business person with quantitative skills. So absolutely pointless on Exam FM. And this is another example of a pointless problem to some degree, but whatever. You have a liability of 12,000 due in 8 years, 5,000. Um, Sorry, the liability will be met with an asset of 5,000 in 5 years, and B in A plus B, little b years. You're employing full immunization at 3%. Calculate big B over little b. I have no idea how to do big B over little b without just getting big B and getting little b. So let's do this. So yeah, this is going to employ a little bit of a, I guess not really a trick, but this, but you want to be a little thoughtful in how you do this, and I'll explain what I mean by that in a minute. And yeah, this is number 57 in the updated 2024 sample questions on the SOA website. Um, so yeah, actually, let me pull that up. Actually, let me do this. Just so I have plenty of room. Second. Works. Okay. Right. Okay, perfect. All right, so let's draw a time diagram. Can't hurt. So the assets are at 5 and 8 plus B years. B is assumed to be positive. I guess it doesn't say it's positive, but for this problem, you have to assume it's positive because otherwise you're not in the full immunization situation. The liability occurs at 8 years, and that's 12,000. So let's do that in red for liability and green for your assets. I'll stick with black after this, but 5,000 big B. All right, so we're gonna price everything at T equals 5. Quite easier. Right, so actually don't need this. All right, so get the present value functions at T equals 5. Just like before, if you want to scrap the 5, you don't have to write it. As long as you do it correctly, it's fine. So this is just 5,000. Discount this by 5 years, so it's going to be well, yeah, discount it. Sorry, discounted by 3 years. Discounted by 3 minus B. Maybe explain that a second. Down. So this is 3 plus little b years. So 0 to 5 is 5. 5 to a plus b is 3 plus b for a total of 3 plus b years. So I have to discount by 3 plus b years to get this big B to 5. So simply big B. If you really want to just take present value of everything, you can. It's not much harder for this problem. Okay, and present value of my liabilities, my liability, one of them, you just discount by 3 years. Right, and now I take derivatives, easy peasy power rule as usual. Yeah, I'll tell you the trick how to easily do this. Minutes. So this is just minus 3 minus little b. Big B 1 plus I to the minus 4 minus little b, and derivative of liabilities with respect to I. Just drop the minus 3. Minus 3 times 12,000 is minus 36,000. 1 plus I to the minus okay. All right, so I will call this here 1, kind of like I did in the previous video when I had the Reddington conditions listed. So yeah, at 3%, that's what we're given. I want to set these two to be equal. Call that 1. So 5,000 plus big B 1.03 minus 3 minus B is equal to 12,000 1.03 to the minus. So the easiest thing to do is solve for big B 1.03 to the minus little b. That's the easiest thing to do. It's a little weird to do, but trust me, that is the simplest thing to do. Otherwise, I don't really know how you would do this problem. I'm not sure I'm not sure why you would do anything else, honestly. So yeah, this is easy. So I would subtract off 5,000 first. And then what I would do, and I'll do this in orange, just multiply both sides by 1.03 to the positive 3. So then that would cancel this here. Right, so let me do that. So yeah, this cancels this here. So this just becomes, this goes away. And so does this. Did I say solve for big B 1.03 to the little b? If I did, I meant big B 1.03 to the minus little b. It's just a natural thing to solve for. Yeah, and I do not have this calculator uh, somewhere here. Bear with me a second. But yeah, and this is really easy. Just kind of do step by step now, and then solve for what you get. Solve. Store what you get. Store what you get. Okay. So 12,000 times 1.03 to the 3 negative minus 5,000 thing times 1.03 to the 3. You get 6536 37. Back there. Let's go. So yeah, they're not asking you for this quantity, but again, this is kind of the natural, obvious thing to do. Maybe not obvious, but it's the natural thing to do, as we'll see in a second. Okay, so perfect. Now let's look at derivatives. Plugging in 0.03. I'll call that 2. So yeah, again, like we did in the last two videos, I'll call setting the derivatives to be equal to. Okay, so let's just multiply both sides by -1 to get rid of the annoying minuses. So it's going to be 3 plus b. And multiplying both sides by -1. I guess I could just factor out the minus. Yeah, let me not do that. Let me just at the very least factor out a minus. So now it's b 1.03 minus 4 minus a little b. That's what happens if I plug in 0.03 here. Sorry, 0.03 here. Then 36,000, 1.03 and minus 4. Okay, so what I would do is minus sign. So yeah, definitely get rid of the minus. But more importantly, what I would do is write this as 1.03 to the -4, 1.03 to the minus b. So this is 3 plus b. I'll do the minus b first for obvious reasons. This rules of exponents. And the obvious thing is that I know what this is. So yeah, this is pretty easy. Um, right, so this here is 65, 36, 360. All right, so I think I stored it in the one spot. Just in case I make a mistake. So take this times 1.03 to the 4 negative. I mean, you could cancel that from both sides. It doesn't matter really. Um, yeah, I would do 1 over times 36,000 times 1.03 to the -4. Should have math in here, but I do it again. That's why you save it. Again, you can cancel the 1.03 and -4, both sides. Weird. This times 1.03 to the 4 minus the 1 over. We have this 1 over times 36,000 times 1.034 minus. Okay, and that's what, so let's do 5.508. Black. 5.5076. So just subtract 3. 2.5076. All right, and now we can get big B very easily, really just from here. It's annoying me. In particular, yeah, just plug in right here. So yeah, we know this is 2.5076. All right, so as simple as store this in a 2-spot in case I need it. So 1.03 to the recall 2 times recall 1, 7039 27 is what big B is. uh Again, literally all I'm doing is solving for big B here. So just multiply both sides by 1.03 to 2.5076 to get big B is 703927. And so, again, just in case I'm going to screw this up, I'll store this here. So this is big B divided by little b, 2807. So this divided by this here, 2807. And which one is this? 2807. So round to the nearest decimal, nearest penny. Well, the answer is A, and you can check that this is the solution. All right, well, that's it. There is one topic I did not do on exam if in this course, and I really should make a video on it one of these days. That is callable bonds. That's pretty easy though. Yeah, I don't know if I'll do it or not. It's a bit of a pain, but it's pretty easy. But otherwise, yeah, everything is done here. The whole exam FM. Yeah. All right, well, hopefully you enjoyed this. So long, take care. Bye-bye.